I'm Pat Dugas, and this screencast is about solving radical equations and inequalities. So the key in solving radical equations and inequalities is going to be to isolate the radical term on one side of the equation. Because what we're going to do after we do that is raise both sides of the equation to the power that's the same as the index of the radical. And because those are inverse operations, that's going to get rid of the radical. Finally, we're going to solve the resulting equation. Now, I usually don't show checking your results for time purposes in screencasts, but it's essential you check your results because you could wind up with solutions that are not valid. So let's solve the radical equation, the square root of y minus 2 minus 1 equals 5. So the first thing we want to do is move the negative 1 over to the other side by adding 1 to each side. So when we do that, we get the square root of y minus 2 equals 6. Now we've isolated the radical, and we can get rid of the radical, which is, in this case, a square root, by squaring, because those are inverse operations. But of course, in algebra, for what we do to one side, we have to do to both sides. So we get the square root of y minus 2, quantity squared equals 6 squared. That is going to eliminate the radical. And so what we'll wind up with is y minus 2 equals 36. Then we're going to add 2 to both sides to get y equals 38. Now it's important that you check your solution in radical equations because sometimes you can come up with solutions that are they are called extraneous solutions. So you get y equals 38. We're going to check our answers. And when we substitute in a 38 for y into the original equation, the square root of 38 minus 2, all minus 1. And we get, so the 38 minus 2 becomes the square root of 36. That simplifies down to 6 minus 1. We get 5 equals 5. So it is true. 38 is our solution. Let's look at another example where it doesn't work out. So I have the square root of x minus 12 equals 2 minus the square root of x. Now you can't really isolate the radical here, so you're going to have to go ahead and square both sides. If it's not possible to isolate the radical, that means you're probably going to have to do some distribution. So we do square both sides. When we do that, on the left side, we get the radical and the square canceling each other out. On the right side, we have to distribute this. So this becomes 2 minus the square root of x times 2 minus the square root of x. And when we go ahead and distribute those terms, 2 times 2 is 4. 2 times negative square root of x plus 2 times negative square root of x gives me negative 4 square root of x. And then the last term is negative square root of x times negative square root of x, which is actually positive x. So this is what we're left with after we square the right-hand side. So we can subtract the x from both sides and subtract the 4 to isolate the radical now, because now we've only got one radical left. When we do that, we get negative 16 equals negative 4 square roots of x. So let's divide by negative 4. And so we get 4 equals the square root of x. Now we're going to go ahead and square both sides to get 16 equals x. But let's check our work. So let's take a 16 and substitute it in everywhere we see x into the original equation. So we get the square root of 16 minus 12 equals 2 minus the square root of 16. When we work that out, we get the square root of 4, which is 2, equals 2 minus the square root of 4, or 2 minus 2 equals negative 2. Well, that's not right. This is not a solution. That 16 is a so-called extraneous solution. It is not valid. Therefore, there is no solution to this radical equation. Let's look at a cube root situation. So we have the quantity 3y plus 1 to the 1/3 power plus 5 equals 0. So we want to isolate this 1/3 part, okay? Because it's essentially like a radical. Because you'll recall from our previous screencast, this is exactly the same as the cube root of 3y plus 1. So we're going to subtract 5 from both sides, giving us 3y plus 1 to the 1/3 power equals negative 5. Now we're going to do the inverse operation to this cube, and we're going cube root, and we're going to cube it. So if we take 3y plus 1 to the 1/3 and cube it, and we take negative 5 to the 3rd and cube the other side, that's going to eliminate the 1/3. That leaves us with 3y plus 1 equals negative 125. Now we're going to subtract 1 from both sides to give us 3y equals negative 126. And then divide by 3 on both sides to get rid of the 3. And our answer, y equals negative 42. So we've got to verify this to make sure that negative 42 is a real solution, a legitimate solution, and not an extraneous one. Put in a negative 42 for y. We get 3 times negative 42 plus 1, all to the 1/3 power plus 5. That evaluates to negative 125. Negative 125 to the 1/3 power plus 5. Well, negative 125 to the 1/3 power, the cube root of negative 125 is negative 5, because negative 5 times negative 5 times negative 5 is negative 125. That gives us negative 5 plus 5, which is 0. And since the original equation equals 0, that checks out. Therefore, y equals negative 42 is a legitimate solution to this cube root equation. So let's look at solving radical inequalities. Pretty much the same as solving other types of inequalities merged with our new process for solving radical equations. If the index of the root is even, though, you need to identify the values of the variable for which the radicand is non-negative. In other words, in step 1, if we're taking an even value, like let's say x minus 3, well, what's inside this radical has to be greater than 0. So we're only going to look at x values that are greater than, in this case, or equal to 3. If it was a cube root, an odd root, it doesn't matter because we could have negative solutions to that. So then we're going to solve that inequality algebraically and test values to check your solution, very similar to other types of inequalities. Let's look at an example. So we're going to solve the square root of 3x minus 6 plus 4 less than or equal to 7. So the first thing we got to do is, since it's a square root, it's an even, then 3x minus 6 has to be greater than or equal to 0. We're going to set up this inequality to determine the values of x that can even be part of the domain of this. So 3x minus 6 greater than or equal to 0. When I add 6 to both sides, I get 3x greater than 6 or equal to 6. Divide by 3, of course. And I'm going to get x greater than or equal to 2. So the only x's I'm going to look at for this are x's greater than or equal to 2 on the number line. Those are the only values of this inequality I'm even going to consider. Having done that, we're going to go ahead and isolate the radical by subtracting 4 from both sides. And that gives us the square root of 3x minus 6 less than or equal to 3. Now we're going to square both sides to get rid of the radical. When we do that, we get 3x minus 6 less than or equal to 9, because 3 squared is 9. Now we're going to add 6 to both sides, giving us 3x less than or equal to 15. Then we're going to finally divide by 3 to give us x less than or equal to 5. The solution is the intersection of both of these. It is less than or equal to 5 and also greater than or equal to 2. It's an and, okay? So it's an intersection. So our final solution is only the answers, only the values of x between 2 and 5 inclusive are part of the solution. Now we should probably test a number out like 3 to make sure it's true. 3 is between 2 and 5. So if we put in a 3 into this, we'd get the square root of 3 times 3, which is 9, minus 6, plus 4. And that would need to be less than or equal to 7. So that becomes the square root of 3 plus 4. And the square root of 3 is approximately 1.72. We'll just call it 1.7, but it doesn't matter because 1.7 plus 4 is equal to 5.7 approximately. And that is definitely less than or equal to 7. So the solution checks out. This screencast has been about solving radical equations and inequalities.